let us continue our discussion and see how to construct formally a push down automaton for this language. Remember 0, 1 or 0, 1, we said we may associate a single one or a pair of ones for a 0, which means supposing for 0 I perform push capital A, then when we see a 1, what is that we should do? Remember, we are associating either pair of ones or just a 1. Which means there are two things. When you see just 1, you pop 1A. Okay. Or you can also look at it this way. When you see 2 ones, you pop 1A out. So how do we model this? If you see a 1, you pop 1A out, then which means 0 corresponds to 1. And for 2 ones, you take 1A out. So which means when you read the first one, you do nothing. Then go to the next one. When you read the second one, because finite automaton, in particular finite automaton, push down automaton, all of them can only read one symbol at a time. So a machine cannot read 2 symbols at a time. Although I say for 2 ones you pop 1A out, what does that mean? When machine reads this one, do nothing or skip and read the next symbol. Okay. Now when it reads the next symbol, which means it is reading the second one, you pop 1A out. For second read, pop A. So how do we formally write this part? So the essence is this: when you see a 0, push A, and for 1 you pop this, and for 2 ones you pop this. Now this in turn tells you, for this one you do nothing, for this one you pop 1A out, but you are only reading one symbol at a time, which means for 0 it is push. When you read a 1, there are two things. This says pop, this says you skip, do nothing. So 1 says you pop A, another one says you skip and read the next one, and for which pop A. Now this is precisely non-determinism. The model or machine does not know at this point in time, when it reads a 1, should the machine take this direction, pop A out and go to the next configuration, or skip and read the next one. And once you read the next one, you go for pop. So what is that the machine should do when it reads a 1? It is this or this. So it's kind of uncertain. Machine guesses and identifies whether it should take this or this. So remember, if it is a non-deterministic machine, at least one configuration, one sequence of IDs, instantaneous descriptions, should take us to the accept state. If that being the case, then we say the string is a valid string. We will experiment with a couple of examples before we describe formally. For example, you say 0, 1, 1, and at this point in time, machine says read a 0, push A. Now, machine is reading this. Now, two configurations are possible. One says Z not A. One says you skip 1, which means you don't disturb the stack at all. Another one says Z not pop A, so which means the A is popped out, A is popped out. Now at this point in time, the control is reading this one, because we either get this or this when we are here. Now control at this place. Now what happens? Now from this, it says skip 1 followed by pop for the next one. Stack becomes this, input is empty. Now look at this. Now stack is empty, but machine is still reading this. So machine doesn't know what to do next. So now at this point in time, you have machine is reading this, stack is just Z naught. The machine doesn't know what to do next. So this branch will not give you anything. So this has to be rejected, meaning this direction will not take us to the final state. Whereas this sequence of transitions will take us to the accept state, because input is empty, stack is empty, and this is a valid input, you accept. So which means when you trace, there will be multiple branches like this. If at least one takes us to the final state, meaning input is empty, stack is empty, we accept. We don't bother about other branches. Other branches you will have incomplete configuration, meaning stack may not be empty, or stack is empty and input is not empty, so all that will be there. Those branches have to be rejected. If at least one branch takes us to the accept state, we accept the string. If all branches say in kind of the configuration is incomplete, input tape is not empty, or stack is not empty, or both, if that's the case, we reject those branches. If all of them are incomplete, then we reject such a string. Let's look at one more example, and then we formally describe the machine. So consider this input, 00 followed by 111. So 1 says this 0 is associated with this 0 is associated with this pair, or 0 0 111, with this you associate this pair, with this you associate this, or it may be like this, with this you associate this, with this you associate this, and now this configuration it is of no use. But just because of this, I cannot say it is invalid string. The reason, this is a valid sequence of moves taking me to an accept state. This is a valid sequence of moves taking me to an accept state. So at least one is present. So this string is a valid string, belongs to this language. This configuration we reject. Okay. So for example, to start with, it is Z naught. and from Z0 1 says when we read two zeros it becomes this, because our description says for 0 push A. Now from this what all can happen? Okay. One says you perform pop A, that is one branch. Another one says do not pop now, you skip. So skip that one. And in the next iteration it says you pop, so this is what you get. Now this one will be 0 0 1 1 1. Now 0 0 A is pushed. Now for the first one we skip, for this one we pop. Now control is at this place. Okay. Now in the next configuration you say pop, and then you see that it is a valid sequence, you accept. Fine. Now this one says you pop A, then input configuration is 0 0 1 1 1. Okay. Now after this, now control is here. One direction says pop A, another direction says skip 1, which means it is Z0 A. In the next iteration you pop, it becomes Z0. This says you pop, you get this. Now if you look at the input 0 0, now control is here. Now in this we are exhausted, which means this is valid, you accept. But this one is this configuration is invalid configuration. But at least one branch is taking me to accept state, therefore it's a valid string. If at least one sequence of moves starting from say Q0, Q0 is the start state, with start stack symbol equals Z0. If at least one sequence of moves starting from Q0 with this and starting from this, if at least one sequence of moves reach the final state, then accept the string. Means it's a valid string, it is part of this, reach the final state, and in this there are three branches, two of them are correct and one is invalid, you reject. But there is one sequence, at least one sequence of moves starting from Q0 reach the final state, you accept the string. Fine. Now let's formally describe.